Okay, so we have been discussing about the common drain configuration. So now we will look at the source, and we see what exactly the looking in impedance or looking resistance in that common drain structure. Okay, we'll see in different drain resistance how exactly this Rin changes. So this is actually the expression. If you remember, that is good. And let's see the derivation. Derivation is also simple. So basically we are looking at this resistance over here. So gate is incrementally ground. So we have resistance RD, right? We have a resistance RD over here. Now you see what is VGS. It is basically minus VX. So this is the current, and this is our resistance R naught. Now you can use current instead of downward. You can use upward. So you can use plus VX. Now you just have to apply the KCL over here, and we have two equation. One current is basically this current, that is basically your VD by RD. This current is same as this your IX current. Okay, and if you apply KCL over here, then you will get this IX current is basically sum of these two currents, this GMVX plus that the current through the R naught. Okay, VX minus VD by R naught. Okay, so now you just solve this equation, you will get this expression. Very straightforward equation. And so then you will see different condition in which how this Rin changes. That is important. So what is Rin? Rin is basically R naught plus RD by 1 plus GM R naught. So very often we use this approximation. This Rin is approximately equals to 1 by GM. That is only true when your RD is very small compared to R naught. If you consider ideal MOSFET where R naught is infinity, in that case generally you can approximate this as a 1 by GM, but depending upon the situation you can see basically if you have an ideal current source R naught, I naught, and in that case you will have Rin equals to infinity because RD is infinity. And if you have incrementally ground, if your drain is incrementally ground, then you can replace RD by 0, then you will get this expression. And on this expression, if you apply that R naught is also, if you can ignore the R naught, in that case your expression will be simply 1 by GM. So this is what you can remember, and yeah, that's all about this.